Hello everyone. Test, mic test, can you all hear me? You all can hear. How come my side like not nothing on? Okay. Can already. Okay, let me try to get this up on my tablet. Sorry for the delay. Hello, Rose, Janavi, Ang Wei, Destiny, Jessica, Kok Kyong, Christine, Suzlin, and so on. Okay, thank you for being here. Okay, never mind, I'll just use my phone to view the comments. So anyway, if this is your first time here, if you haven't downloaded the notes already, you can do so at our blog site where we archive all the Facebook Live coaching in 2019. Okay, so there's a few people who have difficulty logging in. I'm guiding them now. Okay, so anyway, thank you for your patience. Alright, so welcome to today's Facebook Live. Happening every Wednesday at 8 p.m. Brought to you by Maths Heuristics. So a bit about myself. I'm Kevin Huang. I'm the curriculum specialist here at Maths Heuristics, and I've been working here since 2011. Hopefully there'll be many more years for me over here, because I really enjoy what our company is doing, and I truly believe in my boss' vision, Mr. Sani Tan, who is the author of the Mastering Heuristics series and also the founder of this place. He is an ex-teacher with more than 20 years of teaching experience, and there are several projects that I've been involved with that I won't discuss today, because today I want to discuss with you the role of heuristics in primary mathematics. So first of all, this document is the mathematics syllabus for primary 1 to 6 implementation, starting with the 2013 primary 1 cohort. Okay, this is the most updated syllabus. And let me just take a few excerpts from here that are quite interesting. Okay, learning mathematics, a 21st century necessity. Now, the reason for learning mathematics is because it is a key fundamental in every education system that prepares its citizens for a productive life in the 21st century. Okay? There are important 21st century competencies that we must imbue inside our students so that they can lead a productive life and be lifelong learners. And all the 21st century learners are going to be digital natives comfortable with the use of technologies, who are going to work and think differently. Okay, so this is the big picture that they are working towards. And let me just show you what heuristics are. Okay, what better way than to pull this up. Now, heuristics are general rules of thumb of what students can do to tackle a problem when the solution to the problem is not obvious. Okay, there has been a few questions in the recent PSLEs and even in the 2018 PSLE, which I'll be covering one of them today, that has this criteria where the solution to the problem is not immediately obvious and you can't really use units and parts to solve it. Okay? The students should have the opportunities to take notes and organize information meaningfully, practice basic mathematical skills to achieve mastery, use feedback from assessment to improve learning, and to solve novel problems using a repertoire of heuristics. Okay? And you can see that reasoning, communication, connections, applications, thinking skills, and heuristics are important in mathematical problem solving and beyond. And students should be exposed to heuristics and use problem solving approaches in class. And you can see that from here onwards, the mathematical processes often includes heuristics as the higher tier skill. So these are important to get every single last mark that you can in order to secure the highest possible grade that you can achieve. So there are heuristics such as drawing a diagram, tabulating, guess and check, working backwards, simplifying a problem, and considering special cases. So is there a universal method that works for them? I'm hoping to find out as well, but so far I haven't found any. And you can see that from primary 2 onwards, the use of heuristics often pops up inside the curriculum. So the school has been training them on applying and using heuristics to solve these problems. And there are several problems in our real life that we can't solve with. There are several problems in real life that we can't solve with formula. Like for example, supply and demand. In mathematical economics, that is very neat. But in order to derive a real supply and demand curve, you need time, you need data. And to be honest with you, once you have acquired that data, will the supply and demand change again? It's very hard to tell. So there are certain rules of thumbs that we have to use in solving real life problems. Okay, this mathematics designed in Singapore is designed for problem solving. Okay, and this whole AI versus human issue, do you want to know where humans are better than the AI? It is in judgment. That is something that the AI lacks. They can only operate on data at this point. Until they have formed human judgment and instinct, I would say that human judgment is the main skill that we all need to cultivate for this 21st century. Okay? So, let me introduce you the role of heuristics in primary maths. Now I can switch back to my dark mode. Okay? So let me just show you a few examples where you think it can work, but it is actually not going to work. Okay. Now, Mr. Tan, guided example 1. Mr. Tan bought some sweets for his pupils. Now, if he gives each of them 3 sweets, he would have 16 sweets left. If he were to give them 5 sweets each, he would need another 6 sweets. How many pupils are there in the class? How many sweets did Mr. Tan buy? Okay, so let's look at it this way. I will first do this by the model method because I think it will be clearer. So please go on to the model method first. Now, here's how we can break down the problem. Because we do not know how many sweets he has, we do not know how many pupils he has. So we want to represent the number of pupils with 1 unit. Okay, and before I start explaining this, let me just introduce you the idea on how to go about dealing with case 1 and case 2 problems. You see that there are 2 separate cases that we are considering here. So the whole idea for dealing with case 1, case 2 problems is that let's say I have $100 with me today. Okay? Then I spend $20 in the first case. This would lead me to having $80 remaining. True? Then in the second case, if I were to spend $40 instead, I would end up with $60. Okay? So the whole idea is that, because this is a more obvious example, if I were to work backwards for both of them, if I were to reverse that process exactly, if I were to take back the $20 and I were to take back the $40, I would end up with the same beginning. Okay? I will be doing the models first because I think that is more obvious. Okay, so this idea you have to keep in mind. This is how you solve most of the case 1, case 2 problems. You always want to look at what the after is, and you work backwards for both of them to the same beginning, and you compare it. Okay, that's the whole idea. Okay, so to deal with this problem, you see that his number of pupils is fixed for both cases. He has a certain number of pupils. So if he is to give each of them 3 sweets, he would have 16 sweets remaining. Okay, let me just split the screen first. So how do we deal with this? How do we represent this? In the first case, okay, before I draw out the first case, let me just draw out an actual number over here. He has a certain number of sweets. Okay, so in the first case, if he were to give 1 sweet to every pupil, this would be the number of sweets that he gave out. Okay, then the second one, if you gave out the second sweet to all students, this would be the total number of sweets given out thus far. And if he were to give out the third sweet to all of the students here, then he would have this 16 sweets remaining. Correct? If this was his actual amount, he gave 1 sweet to each of the pupils. This would be the 16 that's remaining over here. Actual. ACTUAL. Okay. Now in the second case, if he were to give each pupil 5 sweets, then we can say that he will be giving each of them 3 sweets first, and then he will be giving them some more over here. And because he's going to need another 6 sweets over here, This means to say that he wants to give each of them 5, but he doesn't have enough. He needs these 6 more sweets over here. Now based on this reasoning, we can say that if we are to compare between these 2 units and the values that they have, the lengths that they have over here, we can say that the 2 units should be equal to 16 plus 6. That will give us 22. So 1 unit will be 22 divided by 2 to give us 11. So we defined the number of pupils here to be 1 unit. And this would answer part A because that is exactly the number of pupils that were in the class. Okay, so this would settle part A. Now for part B, how many sweets did Mr. Tan buy? So here, this is what we want to find. We want to find the actual number of sweets that was bought. And we realize that there are 2 ways to go about doing it. The first one is to find out 3 units and then we add 16 to it. So let's do that. We'll just take 3 times 11 plus 16 to give you 49. Okay, and how do you know that you are indeed correct? Because inside here, when we trace this back to the beginning, in the second case, it should give us the same exact number of sweets. So you can check your case 2 over here. This will be 5 times 11 minus 6. That will also give you 49. Okay, so these are your 2 answers. Okay, so Yo-Yo Zizai is asking why is the pupils 1 unit? The reason for this is that there are 2 things that we do not know over here. Mr. Tan bought some sweets. You do not know the number of sweets, neither do you know the number of pupils. So, in order to deal with this, we have to use units to represent the number of pupils first. Okay? Okay, so it's very good. So this is the model method. This works beautifully when your number of items is still relatively small. So in the second case, when we go on to the units method here, okay, once you have the model done out, it is much easier to do the units method here. So to deal with this, what we want to do is, how many sweets did each pupils get? We want to tabulate all and organize all your information first. You have your pupils, your excess or your shortage, and then the total number of sweets. And there are 2 separate cases over here. So over here we would define 1 unit to be the number of pupils. Shortcut I'll explain in a while. Okay? The unit and model. Yeah. So how many sweets was given out to the pupils over here? In the first case, you give each of them 3 sweets. You give 3 sweets to U number of pupils. You are going to be giving 3 units of sweets away with 16 sweets remaining. So there will be a plus 16 over here. The total number of sweets would be 3 units plus 16. Okay. And secondly, in the second case, you gave out 5 sweets to U number of pupils. You are going to need another 6 sweets over here. So the total number of sweets here must be 5 units minus 6. And what did we mention just now? We mentioned that when you trace back to the beginning, both of them are going to have the same number of sweets. So we can say that 5 units minus 6 is equal to 3 units plus 16. Okay, then to deal with this, we would have to use a model to solve for it. Of course, if you are algebraically trained, you can definitely do this with algebra. That's okay. So this entire bar, we will start out with the negative statement first. This entire bar is 5 units. Take away 6, and now you are left with this portion over here, which is going to have the same length as 3 units and 16. Okay, but when you compare between units with units, numbers with numbers, you will see that you end up with the same exact conclusion as you would for the models. Okay, this is excess and shortage. This is excess and shortage. E or S is excess and shortage. Alright. So now let's do the listing first. So some of you may be wondering, we got the answer already, why want to do listing for what? Okay, there is a reason for this. The reason is that you will need it for later. Secondly, you need to know this in case it comes out in your exam. It's rare, but it happens. Okay? So to deal with listing, what you have to do is to list out your number of pupils first. The number of pupils. Okay, maybe let me split screen first. Come up here. The number of pupils. And because each of them was given 3 suites, there will be a multiple of 3 suites being given out. He would have 16 left over here. Okay? Then now if he were to give them 5 suites each, he would need another 16. So he's short of 16 suites over here. Alright? So when you have all this ready, okay, the whole idea for listing goes like this. I won't list out the entire thing until we get the answer. Okay, this would be rather long. So if you have 1 pupil, I'll briefly describe the idea and then I'll go towards the end. Okay, if you have 1 pupil here, you'll be giving out 3 suites and you would have 16 left over. So if we add back 16, we would have 19 suites over here. Then later on, if we have a multiple of 5, the first multiple of 5 is 5. If you have 1 pupil, you'll be giving that 1 pupil 5 suites, but you are short of 6. So that's just not possible in real life. Okay, that's just not possible in real life. What we are looking for is to see that we have 2 numbers in these 2 rows being the same under the same column because your number of pupils are the same. So if we continue doing this, if you have 2 pupils will be getting 6 in total. 6 plus 16 will give you 22. 2 times 5 will give you 10. 10 minus 6 will give you 4. Still doesn't work out. So you want to continue. Yeah, this is M3. So you want to continue listing this out until you get to the same number of pupils. So if you continue listing this out all the way through, when you have 10 pupils, you would have 30 given out. You add back the 16, you would have 46. 10 pupils times 5 will give you 50. 50 minus 6 will give you 44. So eventually you see that they are converging towards one another. when you have 11 pupils, this will give you 33. 33 plus 16 will give you 49. When you have 11 pupils, 11 times 5 will give you 55. And 55 minus 6 will give you 49. So all the conditions have checked out. We have found the two numbers over here that are the same, which means that this is the same starting point that they had. And your number of pupils here would have to be 11. Okay, so it answers that question in another way. What is that? Okay, can So this is the main idea for systematic listing. When should you use systematic listing? Generally speaking, this is for P1 to P4. Okay? When the solution is not immediately obvious, you can use listing from P1 to P4. For P5 and P6, you are encouraged more to use either the model, units method, or the shortcut. So the shortcut goes a bit like this. Okay, the comments are funny, but okay. So if you know the shortcut, you will be like wondering why I went through everything else with you. Okay, I'll just explain why in a while. The shortcut goes like this. The shortcut is that you say that you compare the difference here. 5 minus 3 sweets each will give you 2. And then some people would teach you to memorize or to look at the gap, whichever way works. The difference between the 16 sweets left and 16 sweets needed is going to be 16 plus 6. That will give you 22. Some of them, I'm not sure exactly how they would teach it. For me, if I were to teach it, I would teach them to look at the model gap. Okay? So once we have the difference ready, we compare 22 divided by 2. This will give you 11, which will represent your number of students. And then we take 11 times 3 plus 16. That will give you 49. Okay, so this will settle part A, this will settle part B. Okay, let me try to zoom this out a bit. Okay, so if you're looking for the universal method or the fastest way to do this, you would tend to just memorize the shortcut and abandon everything else. Okay? Right. So, okay, if you all got it, please spam the like button. Yeah, this you can consider this to be gap and difference also. Is there a formula? Okay, try not to memorize the formula. There are 3 main cases, but I wouldn't encourage you to memorize it. Try to look at it on a case-by-case basis. Okay? Yeah, if you don't get this is okay. Just stick to the model or the units method. Okay? Okay, thanks for your feedback. So let's move on to number 2. So if you are the type that just want to learn the shortcut, get the answer done, get it done and over with, then just submit your homework to the teacher and let her mark, get full marks and all that, you're probably going to get this one wrong. Okay, then let me show you why. Now, Mrs. Ng baked some pies to be packed into boxes. If she packed 5 pies into each box, she is going to have 4 pies left. If she packed 9 pies into each box, she is going to have 8 pies remaining. So given that Mrs. Leaf baked fewer than 50 pies, how many pies did she bake? You can solve the D. Okay. Well, my English isn't perfect, but I'm always working on it. Okay, so Let's look at the shortcut first. Can the shortcut work or not? So let's try this. If you understand the logic of the shortcut, this is what you would do. You would take 9 minus 5 to give you 4. Then the next thing you will do is to take 8 minus 4 to give you another 4 when you compare your leftover. So now what do? We just take the big difference and divide by the small difference. We are going to get 1. So this would mean that we have 1 box. Then you would happily get right this. 1 times 5 plus 4 will give you 9. And you say that the answer here is 9. QED. Quite easily done. Is this true? Does it make sense? Hey, please don't go and spoil Avengers here. No, if you check the second case, like what I mentioned earlier, if you check the second case over here, if you have 1 box, you times 9 and you plus the 8 more remaining, you get 17 over here. And these two do not match up. These two numbers here do not match up. Which means that this whole shortcut fails over here. Then why does it fail? Okay, why is it going to fail? Because your number of boxes are different. It's not mentioned explicitly, but the number of boxes are different. Okay? Game of Thrones. You're so young you can watch that, man. Okay, so here's what's going to happen instead. Because your number of boxes are different, we can no longer use 1 unit to represent the number of boxes. And this is where the entire logic starts to break down. And this is why heuristics is important. Because you need to have the flexibility in order to adapt and to adjust to dealing with these types of unfamiliar problems. So to deal with this, one of the heuristics that we can use is systematic listing. Okay? And although it's kind of frowned upon, it gets the job done. The most important thing is to get the job done. Okay? So systematic listing goes like this. You want to define every box has got 5 pies. So there's going to be a multiple of 5 over here, and there will be 4 pies left. Don't spoil the ending. I know the ending, but don't spoil the ending. There are some people who haven't watched it yet. Okay. Then now the next one is multiples of 9. 9 pies was packed into each box, so there's going to be a multiple of 9, and there will be 8 pies remaining over here. Yeah, you can't do model for this as well, because that assumption of the number of boxes being the same is broken down over here. So you can't really use model for that. So over here, once we have this ready, this will be, we want to list out all the numbers over here first. Okay, multiples of 5, what do we have? Okay, so to deal with this is actually rather long. You bake fewer than 50 pies. So don't worry, they will give you a reasonable range for you to list out. They won't give you something like 1,000 numbers for you to find in between. That's just not going to be fair for the student. Okay, so when you keep on listing this out, (35, 40, 45 over here. Okay, just list out all your multiples first. 9, 18, 27, 36, and 45. Okay, you see that over here, once you've listed out everything, you want to add back all these numbers to test out their feasibility first. So you see that if you add back all these numbers, this is what we are going to get. See, if you try to list out 50 over here, and you try to add back 4 to it, you are going to get 54, which is more than this 50 pies over here. So we do not want to consider this number. Just strike it off, liquid paper it off, erase it off. Anything works fine. Okay, just don't consider it. Try to get rid of as many distractions as you can. So for the multiples of 9, you also want to list all of them out. This will be 17, 26, 35, 44, then this will become 53. So this has 53 inside it, which is more than your 50 pies over here. So we do not want to consider this. So having listed out all the possible numbers, you want to look for two numbers inside these two rows which represent the possible number of pies at the beginning. So we were mentioning that you want to look for the number that is the same in both cases, because at the very beginning both numbers has to be the same. Okay? Okay, that's interesting to hear. Okay, your answer for this question would be 44. So to recap and to conclude, no, it doesn't have to be in the same lane, because over here the number of boxes are different. If you try to list out your number of boxes over here, this is what you would have. Okay, this would be 8 boxes. This will be 4 boxes. So it doesn't have to be in the same lane, because if it's in the same lane, there's no way that this can happen. Okay? So what I want to say here is that there is no universal method. I've been trying to look for one ever since I started teaching. Haven't found it yet, and I don't think I ever will. I've always wanted to exceed my boss, to be very, very frank. If he is watching this, good. I've always wanted to exceed him. But now I know why he's the boss. Okay, MOE has already stipulated 11 heuristics and not one single universal method. Okay, and it will do more harm than good if you are trying to teach one universal method to your child, because it's not going to prepare them for things like this. Okay, so this is guided example 3. Of course, one can argue that the universal method for solving problems is math. As my P5 and P6 kids in 10OP would always say, I will ask them a question, something like, okay, what would you do from here to solve this problem? Then they will all go like, oh, I'll do some math. Technically, I don't think that's wrong. Okay, so in PSLE 2018, last year, I worked so much that I just realized that this is last year. Okay, last year only this question came out. Okay, there is also a similar problem to this within PSLE 2018. If you have the book, go and check it out. PSLE 2018, paper 2, question 17. Also involving the use of heuristics and reasoning. You should go and check this out. Okay? My mom say you pour very well. No, it's not pour, it's heartfelt words. Okay, so over here, Mr. Tan packed 508 tarts into large and small boxes to sell. And he filled each large box with 20 tarts and each small box with 12 tarts. Now there is one very important condition here. All the boxes were full and there were no tarts left over. This condition is important because this would mean that you cannot put 19 tarts into the large box. That's not going to be fair already. Okay, there is this restricting condition here. You cannot put like 19 tarts into 20 boxes, sorry, you cannot put 19 tarts into the large box and count it as one box. Okay, that's not going to be fair. So, all of them were full, no tarts were left over. Okay? Need to lose hair. No, I'm still very young. Okay? I don't want my hair to drop off at this point. Okay, so to deal with this, what we have to do is, the trend I observe is that all these questions are designed such that they have to be solved by heuristics rather than universal methods. Like, there is a shift going away from units and parts. That is my observation, that's my personal opinion. Of course, you can beg to differ. So let's deal with this with heuristics and reasoning. Okay? Now, if you want the least number of boxes used by Mr. Tan, let's use some common sense reasoning. Would you want one more of the large boxes or would you want more of the small boxes? Okay, let me just type this out. You want the least number of boxes. So do you want more of the large boxes or do you want more of the small boxes? Hey Unicorn, please stop spamming. Okay, stop distracting everyone. Yeah, the answer is 27. Okay, Jessica, yes. Unicorn, I'm not going to answer you. Yeah, Aggie, you got it. Autumn Apple, you got it. Yeah, Shiwen, you got it. Big yeah, Wei, you got it. Okay, so in order for you to have less boxes, right, you want to have more boxes to contain all these tarts. Because if you try to fit in 508, okay, let's just see, if you try to fit in 508 tarts into small boxes, you're going to need 42 boxes, remainder 4, which means to say that you're going to need 43 lah. Okay, 42 plus 1, you need 43. So you want to have fewer boxes, so you want to put them into the bigger boxes, because if you do this, 508 divided by 12, this will give you 508 divided by 20. If you use the big boxes only, you are going to need 25 remainder 8. So this means to say that you are going to need 26 big boxes in order to contain all of them. But over here there is this condition that all of the boxes has to be full and no tarts were left over. So we can't fit in these 8 tarts into the big box. That will be cheating. So what we want to do now is to try and list out. Okay, this is just to get a gauge of the situation. Try to get a sense of the situation. If you're going to use small boxes, you're going to end up with a lot more than if you were to use big boxes. Okay, so this is the whole idea. So now, if by number of big boxes over here, every one of them has got a value of 20, the total value here. Okay, if we have 25 big boxes and the value here is 20, the total value here would be 25 times 20 to give you 500. Okay, so what are we short of? You want this total here to add up to 508. So the shortage here is going to be 8. Or I should say the remainder over here should be 8. Okay, but can this 8 tarts that is left behind be fully packed into the small box? So here we want to test out, is this divisible by 12? So 8 is not divisible by 12. Okay, so we move on to try out another one. If we have 24 big boxes, every big box has got 20 tarts in it. So the total value here will be 24 times 20 to give you 480. So the remainder over here, because these two has to add up to 508, the remainder here would have to be 508 minus 480 to give you 28. And is 28 divisible by 12? No, it's not. Then over here, if you get 23 boxes, big boxes, you have a value of 20. 23 times 20 will give you 460. You'd have 460 tarts over there. The remainder here would then be 508 minus 460 to give you 48. And is 48 divisible by 12? Yeah, it is. So the least number of boxes. Now we want to check if we take 48 and we divide this by 12. This will give you 4. You are going to need 23 big boxes and you are going to need 4 small boxes. So this will give you 27 and this would be your answer. Okay, then for those of you who have the PSLE booklet this year, do check out this question, the last question of the 2018 paper. Okay, because this will involve reasoning skills. Part A is not that difficult, it's not that hard. There's not much constraint for A. Part B is the one that you need to use listing for. And I've already predicted I don't have enough time to cover it. That's why I'm like giving a shout out to this question. It's very, very nicely designed, I would say. Yeet. Yeah, of course I'm watching myself. Yeah. Yeah, you can also think of it that way. There's a lot of ways you can view Destiny Don Lee. I'm addressing your concern. There's a few ways you can view divisibility and multiplication because they are inverse of one another. Okay. So do check this problem out. If you got it, please spam the like button. I understand for most of you, your exams are over. So most of you should be very happy. So let's deal with some problem solving heuristics over the course of the next few weeks. But during the holidays, we may take a break. The first 2 weeks. Okay? So let me just recap first. In my personal opinion, I don't think there's a universal method that's possible to solve. Okay? It's not possible to solve every single thing. The only universal method there is should be like what all my P5, P6 students say. You want to do math to solve the problem. So let me just wrap this up. The heuristics in primary maths. These are the 11 heuristics that are advocated by the Ministry of Education. Okay, using diagrams or models, before and after scenarios, acting it out, systematic listing, looking for patterns, working backwards, guessing and checking, simplifying the problem, making a supposition, solving part of the problem first, and paraphrasing the problem. Okay, then writing on a related problem and using equations is more emphasized in secondary schools. Okay, so for the June holiday workshops, we will be teaching several of these ideas, and you can log on to mathsheuristics.com/schedule. There you can see the entire big picture. Can we use other methods? Yeah, you can. Technically, anything that is mathematically sound, logical, will be accepted in PSLE marking. Okay? So these are the June holiday workshops that we are going to have. Maybe let me try to view it from here. Okay, let me try to view it from here first. And once you're at this page, once you're at this page, you will see that there is this download schedule for 2019 classes. Okay? So let me try to put this up, the link over here. It's mathsheuristics.com/schedule. Okay, you're welcome, Sandhya, Rekha. So I need an excuse to not do my homework. You need to get a dog, then say that your dog ate the homework, then photograph him actually biting the paper. Bad influence. Any other methods? There is one that is described by Vanessa Wong. It's on numerical reasoning, where you look at the ones place. She has a video on that, you can go and check it out. Okay, you're welcome. The numerical reasoning looks at the ones place, if I remember correctly. Okay, you're welcome, everyone. So the schedule is over here. So once you viewed it already, this will give you the overall picture of what we are conducting. And so we are conducting like at least 2 weeks worth. Yeah, you're welcome, everyone. Bye bye, Autumn. Bye, Jessica. Angry faces. How do you know the number of big boxes? Okay, that is an estimate. You can try to take 508 divide by 20 first, in order to determine the bounds. Okay. Hold on. No, I don't mind getting spoiled for GOT, because for GOT I already finish everything. But there are people who are not watching it, or people who haven't watched the final episode, so don't go and spoil it for them. Okay, Cherries, don't go and spoil the thing for people. That's not very nice. How would you like it if I spoil your favorite movie ahead of you watching it? That wouldn't be nice, right? Schedule is the usual program. Okay, the June holiday 2019 workshops is here. Yeah lah, season finale, don't go and spoil it for people. No, I didn't stay up to 12 lah, but I watched all the YouTube videos on the GOT. Then I can roughly piece together how it ends. How it ends, I don't want to say much. Okay? Yeah, it's on the June holiday workshop. You can also feel free to check out our modular classes as well. We'll be starting the heuristics approach to problem solving for P4, P5, P3, P4, and P5. Okay? Well, the ending, I kind of expected it already lah. I kind of expected it. What types of patterns will be covered for P4? P4 is, okay, there will be number patterns and figure patterns. Okay? Then you never see my Facebook. My Facebook never discuss all these movies thing on, because it's not very nice. Prefer to keep quiet about it. Okay, so anyway, the session is over. Okay, I'm glad you all enjoyed it. So please expose your children to heuristics in primary mathematics. This will help them in a long way to come. Okay, this is Kevin from Maths Heuristics signing off. See you all soon. Good night.